Okay, so here's the first real big topic. That intro part is an important topic, but this is the first one that you really have to get down because this really does dictate the rest of the chapter. So if you're struggling by the end of this section and you're struggling at the end of class, do come in because there's a lot to memorize from this section. There's a lot to unpack. So first of all, parallelograms is what we're talking about. And as you can see here in our standards, Common Core standards, prove theorems about parallelograms. That's a specific property and content standard you need to learn by Common Core. So it's a big deal. We've already talked with polygons with four sides as quadrilaterals. Now we're going to talk about a special type of quadrilateral called the parallelogram. It basically analyzes properties of the sides and angles and the diagonals. So first of all, what in the heck is a parallelogram? Well, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay. Notation, you name that with the two little letters or at the four corners A, B, C, D, but then you draw this little parallelogram guy in front of it. So you'd say parallelogram A, B, C, D by drawing a little parallelogram in front of it. Now, one of the things that's going to drive me insane is I'm going to ask you to define a parallelogram. And a lot of you are going to say something like congruent sides and blah, 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 angles, whatever. That's going to come up in a second. Those are properties of parallelograms. But the definition is simply a quadrilateral with both pairs of opposite sides parallel. Okay. Now, there are 6 specific properties our book brings up. 4 of them are in this drawing. Okay. Other 2 are on the next drawing. So first of all, if I move around this point here, okay, hopefully you notice something. Hopefully you notice 2 things right off the bat. Opposite sides of parallelograms are congruent. Okay, and opposite angles of a parallelogram are congruent. Okay, so that's one thing you hopefully notice first. Okay. The next thing you hopefully notice is this. I've got it up here in the drawing. Angles A and B. They are not opposite. They're what we call consecutive. They're next angles, but they're consecutive angles. Well, 62.62 plus 117.38, that equals 180. Okay. And then notice B and C. So B and C, those guys are consecutive angles. They add to 180. C and D, they're consecutive angles. They add to 180. D and A, they're consecutive angles. They add to 180. And no matter what, consecutive angles add to 180. And the last property I'm not good at with this because it's kind of hard to do, but if you get, if I can do it, I don't think I can, it's too hard to make it move that way. Either if you can make one of these angles a right angle, it actually makes all 4 of them right angles. And that's the 4th property of a parallelogram. Now, before we copy those theorems down, kind of to run through this real quick, why in the world does this happen? Well, let me draw a parallelogram. And the classic parallelogram is kind of like a rectangle that you just nudge over to the side. So again, by definition, those 2 sides are parallel, those 2 sides are parallel. That's it. Quadrilateral, both pairs opposite sides parallel. Now, if you go back and you think about your parallel lines, and you think about this guy here being the transversal, this is a pair of consecutive interior angles. Well, guess what? Consecutive interior angles aren't congruent, but they are supplementary. And then if you think of this, okay, again, as these 2 lines as parallel, this transversal here, oh, guess what? These are a pair of consecutive interior angles as well. They're also going to be supplementary. I think I said parallel last one. I meant supplementary. So supplementary here, supplementary here. By the congruent supplements theorem, which we haven't used forever, but we did have it, if these 2 angles are supplementary and these 2 angles are supplementary, that means these 2 guys have to be congruent. And then likewise here, these 2 guys will be supplementary as well because they're consecutive angles, meaning those 2 guys will have to be congruent. So that actually gets us to 2 theorems right there. Consecutive angles supplementary, opposite angles congruent. Now the right angle part of it makes sense because if I made this 90, they have to be supplementary to 90 and 90, 90, 90. So that makes sense. The last part though, congruent sides of triangles, so where in the world do we get that at? Well, if I draw in a diagonal, doesn't matter which, but if I draw in one diagonal, since these are parallel, I now get alternate interior angles. And I already have these pair of angles congruent. these pair of angles congruent, and then by reflexive property, I'll have angle, angle, side, angle, angle, side, which then means the two triangles are congruent, and hey, by CPCTC, this side's congruent to this side's congruent to this side, because those are the corresponding parts. So that's also a key to this, that whenever you have a parallelogram, when you cut it in half, you get two congruent triangles. Okay, so let's run through those theorems real quick. So there are four of them. The first one, and if a quadrilateral is a parallelogram, opposite sides are congruent. Okay. Second one, 6.4. If a quadrilateral is a parallelogram, then opposite angles are congruent. Okay. 6.5, if a quadrilateral is a parallelogram, then consecutive angles are supplementary. And that's the hardest one, I think, to describe in words. Just knowing that basically what it is the non-opposite angles are going to be supplementary. That's maybe a good way to think of that. And then the last one, if a parallelogram has one right angle, then it has four. And again, that's because these two would have to be supplementary. If this is 90, this is 90. Oh, and then opposite angles are congruent, so 90 and 90, 90, 90. Okay, so here we go. First problem, which relates the next few problems. In triangle, parallelogram ABCD, or ABCD is a parallelogram. Find AB. Well, here we go. Here's how I always work this out mentally. We've got a bunch of different theorems. The first theorem said that opposite sides are congruent. So I know this side is congruent to this side's congruent to this side. So I just jumped to this being 30, and this being 20. I'm not going to answer AB yet, I'll answer in a moment. Okay. The other thing I know is this. Opposite angles are congruent. So if this is 36, this is 36 degrees. And then the last thing I know is, hey, if not only are the opposite angles congruent, but the consecutive angles are also supplementary. So if this is 36, measure of angle B plus 36 has to equal 180. Subtract 36, measure of angle B has to be 144 degrees. There we go. And so now we know a lot of stuff about this figure. So let's start answering questions. So the first one is, what's the length of AB? Well, AB was 30. Okay. Next slide. Measure of angle C. Well, that's easy. Measure of angle C is 36 degrees. Okay. And then next, find the measure of angle D. Well, go back to the drawing. Oops, wrong button. Go back to the drawing. Measure of angle D is 144 degrees. So there we go. All right, now, there are two more theorems about parallelograms, and they have to do with the diagonals. So let me go back to my little GeoGebra guy here. So first of all, we've already talked about the first theorem, and that is whenever you draw in, let's just draw this, no, that's not what I want to do. Object properties, label, I want it to be the value. Okay. So the first thing is this. If I have a parallelogram and I draw in one diagonal, I get two congruent triangles, and I get it actually by side, side, side. Okay. Now, the other one is this. If I draw in both diagonals, they meet at a point. That point's point E. And if you look at this, with the computer, what it's doing for me is it's giving me that the diagonals, each part here, this part and this part is congruent. This part and this part is congruent. What ends up happening is the diagonals of a parallelogram bisect each other. Now, they don't bisect anything with the angles, just the sides. And hopefully you can kind of see when I kind of just stretch this guy like this. Those angles there aren't congruent here. But the diagonals still stay bisected. So we have two theorems for diagonals of parallelogram. First of all, well, they kind of did it backwards the way I explained it. 6-7, if the quadrilateral is a parallelogram, then its diagonals bisect each other. 6-8, if a quadrilateral is a parallelogram, then each diagonal separates the polygon or parallelogram into two congruent triangles. All right, so this example is pretty tough. That's why I decided to kind of pick it to walk through and end the video with, because it pulls a bit of everything into play. Okay. So we're supposed to solve for, well, we have, let's see here, we have three variables. We have p's, we have x's, and we have k's. Sorry. It doesn't really matter what we go for. Probably p is the easiest to solve for. So I look at p, it's 2p, that's what it's a part of. We say, what is 2p representing? Oh, it's representing the length of AB. So what do you know about the side lengths of a parallelogram? Because since that's a side length, oh, well, the side lengths are congruent. So 2p equals 22. So first thing, 2p equals 22, divide by 2, p equals 11. Okay, so that's easy enough. Okay. Now the next easiest one probably is to solve for x, because x is part of the diagonal. And we had a theorem that said, oh, well, if you draw in both diagonals of your parallelogram, the diagonals bisect each other, so they cut each other in half. What that means then is 6x plus 2 has to be the same length as 4x plus 12. Okay. So for number 2, set 6x plus 2 equal to 4x plus 12. So subtract 4x, subtract 2, we get 2x equals 10, divide by 2, x is 5. Now, what's probably the most difficult for people to see just outright is what in the world 3k plus 4 is talking about. Okay, because that's what I'm going to solve for k for. Well, notice it's not one of the big angles. It's a part of an angle that's caused by a diagonal. And here's the real key to this one. The diagonal of a parallelogram goes from corner to corner. But what it does is it creates a reverse Z shape in this case, or a Z shape, something like that. And these two sides are parallel, because that's the definition of parallelogram. Opposite sides are parallel. So when I get that Z shape, the angles here at the corners of it, which is what 3k plus 4 is, oh, they are alternate interior angles. So the question is simply, what is the angle BAC, which is what 3k plus 4 is alternate interior to? Oh, it's alternate interior to 25 degrees. Okay. And since it's alternate interior to those two angles, it means they have to be congruent. So 3k equals 21, divide by 3. Whoops, that's kind of dropped there. K is 7. So there's a lot to this section. There's a lot for us to unpack. There's going to be a lot for us to do with 6.2. So if this is a bit overwhelming for you, it's understandable. But again, if you don't get it, come in before school, after school, something, because there is just a lot of stuff in this section. Okay.